Next up is good old H2O, our good friend water. Alright, so let's figure out how we write this up. The first thing, as always, is figuring out how many valence electrons there are. So for hydrogen, we have 2 hydrogens. It's in column 1. So column 1A, and it's going to give us 1 valence electron, and we have 2 of them, for a total of 2 valence electrons coming from hydrogen. Oxygen is in column 6A. So 6A, that means that it's going to bring 6 valence electrons. There's only 1 of them in our chemical equation. So we have 6 valence electrons from oxygen plus the 2 valence electrons from hydrogen, means we have 8 valence electrons total. Now, to determine the central atom here is pretty easy, just because hydrogen can only bond to one thing, so they both must be bonded to oxygen. Otherwise, they'd be bonded to each other, and we wouldn't have H2O, we'd have H2. Another way to think about this is that there's only 1 oxygen and 2 hydrogens. And so oxygen, because oxygen can form multiple bonds. And now we can start drawing out the structure and assigning electrons. So we'll begin by putting down the central atom, which is going to be oxygen, and then on either side of it we'll just connect up hydrogen. We'll count up the valence electrons that have been used here, so 2, 4. 4 valence electrons used, that means we have 4 valence electrons left. Oxygen needs 8 electrons to fulfill its octet rule, and it only has 2 4s, so its rule is not fulfilled. But hydrogens only need 2 electrons to fulfill their duet rule, and they both have 2 electrons, so their rule is fulfilled. Now we just have to fulfill oxygen's octet rule, and the way we'll do that is just to assign all the remaining valence electrons to oxygen. So they go 1, 2, 3, 4. Now our octet rule for oxygen is fulfilled, and we can make up the model. Okay, let's go ahead and make up our model here. So we need an oxygen that has 2 single bonds to 2 hydrogens. So we'll put this together. Bonds first, then hydrogens. You see it's got kind of this bent or V-shaped pattern. So we can verify this by looking at the Lewis diagram here. So with oxygen being the central atom, we're going to look at the electron domains around oxygen. So we have 1, 2, 3, 4. So a total of 4 domains. Of those, 2 are bonding, 2 are lone pairs, and if you look at your table, this will all correspond with a bent or V-shape geometry.